Hi, welcome to this awesome evening. Taji here. Today we are going to discuss some interesting factors related to electrostatics. As we discussed last evening, every Friday we will be uh, the Fridays are dedicated for +2 topics. Okay, so let me share the screen. One second. Yes, I hope that the screen is visible for each one of you. So, one second, let me get back. Yes, I wanted the screen to be visible for you with clarity. So, let us start the discussion with 4 fundamental forces in physics. The first one, as you know, it is gravity. Gravity is considered to be the weakest among all the four forces. The second one is electromagnetic forces. Third one is weak nuclear forces. And the next one, last one is the strong nuclear forces, which is the strongest of all the four. And gravity is considered to be the weakest among the four. When I studied this concept earlier, I was got confused. Why gravity is considered to be the weakest force? We are getting hurt when we are falling down when we walk or we run. Somebody, it will be really detrimental and even leads to death if somebody is falling from the top of a 10-storied building. Even on recent days, one of the opposition MLAs in Kerala, he fell down from a stage to a depth of 15 feet around. Now she is hospitalized and in a critical situation. So my thought was like that. We are getting severely hurt, injured when we are falling down. And it is due to gravity. And I saw mangoes, similarly jackfruits, falling from the tree and they are getting shattered. So according to my point of view, gravity is a really powerful or stronger force. But when started studying physics, in physics it says that gravity is the weakest among all the forces. I was a bit confused. I'm damn sure that as students learning physics, you might also be having similar kind of doubts. So let us address that right now. Now, let me give some deeper insights regarding gravity. As you people are in class 12, you will be knowing gravity in detail, so that I don't want to explain this concept in an elaborate manner. See, there are two masses, m1, m2, separated by a distance r. They will attract each other with a force which is called Newton's gravitational force, which is applicable even for the attraction between Earth and Moon system, Earth-Moon system. And the law which is applicable to each and every particle in this universe is stated by Newton as force of attraction between any two masses in this particular universe is found to be directly proportional to the product of their masses and inversely proportional to square of the distance between them. And we write the equation like this: gravitational attractive force between two masses M1 and M2 separated by a distance R is equal to, given by, G M1 M2 by R square. Here G is the universal gravitational constant whose value is estimated to be 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. See, as +2 student, you should be thinking about the evolution of certain unit for a given constant or variable or some quantity. Here, the unit of G, you will be obtain the unit of G by rearranging this particular equation. See, you place G here and move all the other parameters to the other side. So on the other side, you will be getting Fg, which is force. Then this R square will move to that side. So unit of force is Newton, unit of distance square, that is meter square. Then this mass 1 and mass 2, product of mass 1 and mass 2 will move down on the other side. That is the kilogram square. 1 by kilogram square, it appears as kilogram raised to minus 2. This is the evolution of the unit. Now, I mentioned it occasionally. That's it. Okay, for your reference. Now, if we consider or assign a peculiar situation for these two masses which are kept r distance away, we are assuming or imagining that both M1 and M2 are having unit mass or 1 kilogram each. That means M1 is an object whose mass is 1 kilogram. Similarly, M2 is the second mass, which is also an identical mass whose mass is also 1 kilogram. Now, another condition, special condition we are assigning or we are imagining to this particular situation is the distance of separation between the two masses, let it be 1 meter. So, mass 1, 1 kilogram, mass 2, 1 kilogram, and separation 1 meter. Okay. Now we have the estimated value of gravitational constant as 6.67 into 10 raised to minus 11. So we have all the values coming or appearing in this particular equation. We are substituting all these values. Obviously, the second term means M1, M2 by R square. The result will be 1 because 1 into 1 divided by 1 square. It will become 1 naturally. Then Fg will become numerically equal to G. What is the numerical value of G? It is 6.67 into 10 raised to minus 11 Newton. So this will be the force of attraction between two masses which are or both are 1 kilogram in mass separated by a distance of 1 meter. Okay. So they will be attracting with that much of force. Now, let us deep dive into this result we obtained. See here, this already we got this value. Now, you imagine about holding a mass of 1 kilogram on your palm. You think about a weighing or measuring weight, 1 kilogram weight made of iron or something else. You hold it on your palm like this. You will experience its weight. That means the gravitational pull you will be experiencing, or you are preventing it from falling onto the earth. Simply you think about it. Here the weight is on your palm. You simply remove your hand. Then this weight will fall onto the earth, which means you are preventing it from falling. And that weight is experienced on you, on your palm. So you will be getting the weight of it, which will be equal to 9.8 Newton. This you calculated using Newton's second law. P is equal to mg. M is 1 kilogram and acceleration due to gravity is 9.8 meter per second square. So that you will be getting the gravitational force acting on 1 kilogram mass placed on your arm or palm to be 9.8 Newton, or approximately it is 10 Newton. Now, you consider another situation. These two masses, let both are having 1 lakh kilogram, 10 raised to 5. 10 raised to 5 means 1 lakh kilogram. 100 ton. 1 ton is 1000 kilogram. So 100 ton kilogram mass, one object. And another similar object which is also having 100 tons of mass. So they are kept at a distance 1 meter apart. Now you calculate the force of attraction between those two. See, we should remember one thing here. We are not thinking about force of attraction on 1 lakh kilogram by the earth. We are considering the force of attraction between the two masses which are having 1 lakh kilogram mass each. Okay, you think about it. Now, if we calculate, or if we put those values in this particular equation, which is Newton's universal law of gravitation, F is equal to G m1 m2 by r square. Here r is 1 meter. So definitely second part m1 m2 by r square becomes 1. So Fg is equal to G into m1 times m2. So by multiplying these values, you will be getting 6.67 into 10 raised to minus 1, because this will be 10 raised to 5 times 10 raised to 5, 10 raised to 10 you will be getting. Then when you simplify 10 raised to 10 with 10 raised to minus 11, it will become 10 raised to minus 1. Then 6.67 into 10 raised to minus 1. That is the result, ultimate result. Then it is equal to 0.667 Newton, less than 1 Newton. Now you think about that force with the force you experience when you try to hold a 1 kilogram object on your palm. It is 10 plus times more. See, this is only 0.667 Newton. This is 9.8 Newton. If you hold 1 kilogram on your palm, you will experience a force equal to approximately 10 Newton. But this is less than 1 Newton, or only 0.667 Newton. So gravity is, this is about gravity. Now with this insight about gravity, we are trying to explore the force of electric charges, force between electric charges. Let us switch to that point. See here, this is a 2 kilogram mass, but I told you to imagine about a 1 kilogram block holding on your arm. Okay. Now, one more thing we wanted to think about is that the estimated mass of the earth is approximately 6 into 10 raised to 24 kilogram. So this is the same reason when a person falling from the top of a building, 10-storied building, he will die. Definitely, he will die. Why he is getting such a huge or massive impact? What is the reason for that? Simple. It is due to this huge or massive mass of the earth. Okay. I hope that makes sense for you. Now let us move to the case of electrostatics. Here, electrostatics and gravitation, both the forces come under the same umbrella, which is called as the forces which obeys inverse square law, or both are inverse square law forces. What is common for both? See, in electrostatic force, the force between two charges Q1 and Q2 separated by a distance r is given to be Fe is equal to, E stands for electrostatic force, okay, is equal to K times Q1 Q2 by r square. Here Q1 and Q2 are the two individual charges, r is the distance of separation. Here K, value of K is equal to 1 by 4 pi epsilon, that you might be knowing clearly. Now I'm not going deep into that part. The value of K is found to be 9 into 10 raised to 9 Newton meter square per Coulomb square in the case of free space or vacuum. Okay, that is what you are already aware of. Now, here also we are imagining these two charges, Q1 and Q2, both are identical charges having a magnitude of 1 Coulomb each. Okay, now the distance of separation we are taking to be 1 meter. Now substitute these values in this particular equation. See here Q1, Q2 is 1 Coulomb. So 1 into 1 divided by distance of separation is again 1 square 1. So this part collectively goes to be 1. Then Fe will be numerically equal to K. Okay. What is the value of K? It is 9 into 10 raised to 9 Newton. So approximately, so 9 into 10 raised to 9. If we take 9 to be 10, then we can write it as 10 into 10 raised to 9, that is 10 raised to 10 to the power 10 Newton. That will be the electrostatic force between two charges, both are 1 Coulomb each, separated by a distance of 1 meter. Now you will be getting a clarity while I am going to compare this with the corresponding gravitational force. When we hold a mass of 1 kilogram on my hand, on my hand, what I will be experiencing? I will be experiencing a force of only 10 Newton. But at the same time, in order to maintain these two charges, Q1 and Q2, at these two positions, 1 meter apart, I need to exert a force which is equal to 9 into 10 raised to 9 Newton, or approximately 10 raised to 10 Newton. Now you think about this. If we hold a mass of 10 raised to 9 kilogram on your hand, 10 raised to 9 kilogram mass, how much it will be? 10 raised to 9 means 1 billion. 1 billion is 100 crore. 100 crore kilogram of mass. You simply imagine lifting a small mountain or big hill on your palm. Just like we heard the myth of Hanuman taking Marutvamala, just like that. Okay, so what will be the impact of a small mountain on your hand? Will you be able to withstand or hold it on your palm? Never. So that kind of impact you will experience here in the case of two charges which are 1 Coulomb each, kept 1 meter apart. So here there are two chances. If both the charges are like charges, both are positive or both are negative, in both the cases, they will repel each other. Q1 will try to move this side and Q2 will try to move this side, because both will repel each other, push each other. So in order to maintain them at a distance of 1 meter apart, somebody need to push them from both the sides or hold them from both the sides. With how much of force? With a force which is equal to 10 raised to 10 Newton approximately. And the second case is if both the charges are opposite charges. If Q1 is positive and Q2 is negative, what will happen? Here the case is unlike charges will attract each other. Positive and negative will attract each other with the same force, which is equal to approximately 10 raised to 10 Newton or 9 into 10 raised to 9 Newton. So here the tendency of both the charges will be to come together or they will attract each other, just like a magnet attracts a piece of iron. So they will try to move together. So in order to maintain them at a distance of 1 meter itself, some external agent has to exert this much of force, that is 9 into 10 raised to 9 force in the opposite direction, from preventing them coming closer. It is a huge mass, humongous mass you need to exert, you are supposed to exert. So now you might be able to relate this with the gravitational force. See, when you place two masses of 1 kilogram each at a distance 1 meter apart, the attractive force is only 0.667 Newton. But at the same time, if you place 1 coulomb charge each at a distance of 1 meter, the corresponding force between those two charges are 9 into 10 raised to 9 Newton or approximately 10 raised to 10 Newton. So think about it. Now, this is our first session. Okay, I wanted to give you some insights. If you want to make the best utilization of these sessions, be present with your notepad and pen or notebook and pen. After watching the live session, you do the corresponding calculations or works in your notebook by your own. And after completing the session, after going with this kind of practice, if you are having any doubts, please come back and watch the session from the feed itself. It will be there in this channel itself. So you will be able to watch it again. I'm not sure about, I have not enabled in Instagram, but you will be able to watch in YouTube or in Facebook. Okay. I'm appearing live on all the platforms at the same time. So you can make use of any platform to watch these live sessions. Okay. So make notes. Now I wanted to tell you what is the importance of making notes. See, I'm not going to explain this concept in detail, but I will summarize my point. This is called as cone of learning. This is the outcome of a very famous study by a scientist called Edgar Dale. And according to his study, these two experiences, participating in hands-on workshops, designing collaborative lessons, these two experiences will contribute 70% to your learning. Which means if you are saying something or if you are writing something, you are having a powerful learning experience, which will help you to retain 70% of what you have learned in your memory even after 1 week or 2 weeks. So my humble request to each one who are watching this session is to write notes, whatever be you are learning. Whether you are learning physics, math, chemistry, or even it is language or history or whatever be you are learning, please take a lot of notes, which will help you to have better understanding and to have deeper insights and to have stronger learning experience with this kind of learning. So, my humble request to each one of you to take lots of notes whenever you are learning something or anything. So, this is what I wanted to tell you. One way is writing, the second way is saying. You can teach what you have learned to some others. You try saying what you have learned to some of your friends or to your siblings, or simply you can stand in front of the mirror and speak to yourself. You can teach yourself. You can teach yourself. Okay, that easy it is. So by creating, see, whenever you write or whenever you say something to someone, you are creating. You are trying to express the concept in your own language. Whenever you create, the learning will be more powerful than you consume something. Okay, so be creators, don't be consumers alone. That is my humble request. Again, let me share the screen once again. Again, if you wish to learn more in this way, I invite you to join my free webinar. I'm conducting my free webinars every Thursday and every Sunday. It is a live session. Duration will be 2 hours. And I will explain how I'm teaching physics with 4 core pillars. You will be able to master the subject physics, which is considered to be one of the most difficult subjects for most of the students. My strategies, when it is connected to physics learning, one is simplification, second one is gamification, third one is lifeification, and fourth one is storification. With these core pillars, I will be helping you to experience physics in a better way with deeper insights. And you can register for my free webinar by following this particular link given on the screen right now. So with that, we are stopping the session today. So signing off. Thank you for being here for this much of time. So the next session for +2 will be on Tuesday. So once again, let me tell you the schedule of the sessions. Every Monday and Thursday, I will be handling +1 topics. Every Tuesday and Friday, I will be handling +2 sessions. Every Wednesday and Saturday, I will be handling high school sessions. Maybe 8th, 9th, or 10th, or a mix of some topics which will be relevant for high school classes. Okay, that will be the usual schedule. And all these 6 sessions, Monday to Saturday sessions, will be happening at 6:30 p.m. It will last for some 20 to 40 minutes, 20 to 45 minutes, maximum 45 minutes. Live sessions. Okay. Again, as a part of continuing this journey, I will be appearing live on Sundays also. But on Sundays, I will be discussing some general topic related with physics, which is closely associated with life also. And on Sunday live sessions will be happening at 10:30 a.m. 10:30 a.m. So I will try to deliver the content in a most simplified manner so that each one who are listening to these sessions will be able to follow. Okay, and to upskill yourself. So with that, I'm ending the live session today. So once again, I express my deep gratitude to each one who stayed here for this much of time. So thank you all. Signing off.